All credit goes to these people over here, mainly to Dr. Sarkar. That's the main person. Anyways, we're moving on now. All right, let's go into the topic of, I believe. Let me read this again. I don't know how far we went last time, so I'm gonna have to reread. Did this already, but let's do that again later, okay? Which is a first order scheme, called the first order backbone differencing formula. Higher order scheme more accurately can be derived by Taylor series as a function of f as different points from xj. For example, the widely used central difference can be subtracting two Taylor series, assuming that the space data we have. Just so you know, we're going to do the table way. Because we have Fi, right? And we have Fi minus one, I think, and Fi plus one. And I think that's all. I'm not forgetting something, am I? No, I'm not. I think I'm right. And then we have Fi, and then, oh, I'm forgetting AO, a negative one, and A1, F prime of I, Fi double prime. Also, this is be J, I think. We'll fix everything up later. J triple prime. Now, if I remember correctly, we're trying to figure, oh, I think I'm forgetting Fi, which is 0, 1, 0, 0, 0. Forgot that one. That's what we're trying to get, right? Center differencing. Okay. And then we're going to do A0, 0, 0. Do we need a fourth one? Maybe we do. A negative 1, A1, right? Because that's how it works. And then it would be, I think it would be A. Let me just check Choice series. Choice series is F prime is one of them, so it's A negative 1, I think. Yeah, that sounds correct, right? And then you so on and so forth, I believe. You could double check your Taylor series by looking at this stuff. But yeah, yeah, okay. No, it's F prime. So it's H. I was wrong. Sorry. A1, H squared divided by 2, A negative 1, H squared divided by 2. So no, I did this wrong. It's a minus here. And H squared cubed divided by 8, I think. Negative A1. And then positive H cubed 8A minus 1. Let me check if I'm correct. I probably am. I'm just not sure. No, I'm not. It's 6. Okay. And with that said, we can plug it into our F prime equals summation of k equals to whatever n needs to be, and it's fj plus k, and that is what we need to do. Basically, we need to add up these things. So it is AO plus a negative 1 plus A1, and this is our F prime, no, not F prime, F. And then this one over here is 0, and we have this, I believe this H over here. I think all of them have H's, but there's a negative HA negative 1, and there's a positive HA1. But I need to double check if that's correct. Yes, it's negative, yeah. F F prime, and that's plus uh H squared, and then this is a negative 1 plus H squared 2, A1, which is then plus by there's a F double prime here, and then there is a plus H cubed divided by 6, A negative 4. Oh, I forgot 1. This is what I was forgetting. There's a 1 there. I knew I forgot something. And then there's a negative here, and there's a positive H cubed divided by 6, A1 parentheses, so on. Now we're doing finite differencing, so I believe it is first order, second order or something. It is second order, so I'm gonna stop here. This part's not needed. So A0 plus A negative 1 plus A1, H A negative 1, negative plus HA1 equal negative 1. And the third equation that we need is H squared divided by 2, A negative 1 plus H squared divided by 2, A negative 1, A1, and that is equal to 0 because this is approximately true. Now, how do we get the rest of it? You just have to solve it. Now, is it just me or this looks like this? I think something's wrong here. Unless I'm being a fool here and guess I guess I didn't need to define a difference from this one. A1 equal negative A1 and plug it into here, which will negative H, which will give me A1 negative, so it's positive, plus HA1 equal negative 1. So that's 2A1 equal negative 1. So A1 equal negative 1 half. And then A2 equal 1 half. Is that correct? Yes. Oh, Surprisingly, I didn't make a mistake here. Oh yeah, A0 equals 0 because that satisfies this, obviously. Uh, I shouldn't say, no, not obvious, but you get what I'm trying to say. Okay, that gives you this form here, f prime equal, and this is the hard way to do it. The easy way is to just do the way that the book tells you to do it, and not the way that I did it. Don't do it the way I did it. I recommend you don't do it that way. But if you did do it this way, and you went over here, you went and looked for what's the order of this, right? Because you clearly can get the once again, this is not enough. You need to figure out where is that? Oh, you need to figure out what order is this, which is plus the order of h squared. But in reality, it is order of h squared divided by 6 f prime. And now, what is this form here? Now, we can do a bunch of other stuff, but look here, and then look at the division symbol over here. So that's it. That's how they did it. That's not too outlandish, I believe. Let me double check. We can do it. So now, let me erase this and do it for you. If I were to check the fourth prime over here and look up what would happen if I plugged in these values, it should just tell me. Negative 1/2 plus h cubed divided by 6, 1/2, which equals h3 divided by 6. There we go. There is your answer. And then obviously f prime. Touching. Now we're going to do this with the other ones too. I do not remember. I think there's an exercise that I should be doing. I just forgot which one. Um, yeah. And then with that, we got our central differencing done. So I guess I think we did backward differencing. So this video would be on central. So I guess central differencing is done. Okay, I like this one that we're done with this. Um, we're done with this part. Oh, that looks ugly. Let me not do that. And then obviously there's a higher version. Okay, fine. We finished how to get this part. Next time we'll do the fourth order one for fun. Um, because we'll do it one video at a time. This will be central differencing. Okay.